So we have the title here, AI was never meant for humans. I don't quite remember when we came up with that title, but you'll see how it fits into it as we go here. Alegion, just real quick, Alegion is an AI and ML training data platform. We help companies drive to ground truth. We basically help data science teams get to confidence in their models as their models are being developed through the AI lifecycle. Our big advantage is we can do it very high quality and at any scale. So that's really our sales pitch there. We're in Austin, Texas. So it's a little chilly up here, but we're coping okay. We focus on enterprise, as you can see here on our palette, if it's up there. You notice we're not specifically in any specific vertical, except for the fact that all of our customers have a great deal of data. That's really the commonality. So our customers have a huge amount of data, and they're trying to build new applications and new technologies around machine learning and artificial intelligence to leverage that data to stay ahead of who might be coming behind them. I want to talk a little bit about training. I want to talk about kind of the way that AI looks at training, the way that AI looks at use cases and driving to confidence within those use cases. And when we do that, we talk about the edge case, and we say that the devil is in the details and the tyranny is in the edge case. And the analogy we use a lot is boulders, rocks, and pebbles that you might have used in or seen in other scenarios. But it's very easy to go and find an algorithm that you've downloaded, an open source algorithm, and then maybe a readily available training data set that you can do the initial training on that algorithm and get to a pretty good level of confidence very quickly, at least enough to show the board or to show the management team, hey, we could really do this. We could really separate the A's from the B's in this scenario. We could really propose the right solution in this scenario and demonstrate that this would work, right? So we often see that at this early stage, customers can very quickly get to a level of confidence in a model using readily available data sources that can demonstrate the value of an AI project, right? We call that boulders because with a very little amount of training and a very little amount of effort and refinement, you can get to a pretty good level of confidence pretty quickly, and that's when projects are sold internally. After that, you start to throw more kind of use case scenarios and training into the mix, and we call those rocks. So if you think about it, maybe the project is a chatbot, and maybe right off the bat using an open source NLP engine and maybe using some basic training on some linguistics for English or some things like that, we can get to 50 or 60% confidence in the chatbot model. But we probably need to be a little bit higher than that before we're going to start replacing CSRs with the chatbot, or we're going to see any substantial value from that. So we need to train down to the use case. If we're an appliance repair company, then we need to train the chatbot to understand what the difference is between a refrigerator and a microwave and these different things, right? So we start doing specific training to the use case level, right? And once we get the preponderance of the main use cases covered in our training, we start to see, okay, we're creeping up in the overall confidence of the inbound of these inquiries, and we're starting to see some real value. And that's when we first deploy it within our organizations. That's when we see enterprises first start to deploy the AI solution, when they take the initial readily available training data set that they can find out there quickly, and they supplement it with often human-derived or supervised data that is specific to their use case within their own company. But really where the value is when what we call the pebbles, everything that fills in all of the gaps, which are really the edge cases, okay? These edge cases are where we see one company separate themselves from other companies within the same industry around similar solutions. This is the difference between when Google Assistant first came out and Siri first came out. It was those edge cases. It wasn't the easy things like, what's the weather going to be today? It was the really frustrating things that hurt the user experience because that edge case wasn't there when you asked it for that. So differentiation and dominance within an industry happens at the edge case. And as you can imagine, the edge case takes a tremendous amount of training. And it takes a tremendous amount of data to identify all the different facets of the edge cases. And we'll look at some of these. But this is really where we see AI start to become self-dependent on identifying these things. Now, here's our confidence curve here. As we deploy a model and we get our model out there, the data science teams initially are always tracking the confidence on the inbound source data that's coming in, and how confident is the algorithm in the answer coming out, whether it's a chatbot, whether it's computer vision, or whether it's an entity mapping type scenario. And we can find out real quickly, okay, well, here's where I need it to be an ROI. My chatbot needs to be at least this good before I can start replacing CSRs, right? Or, you know, maybe my application's more complicated. Maybe it's doing diagnostics, looking at CAT scans. And maybe it's much more complicated, and I'm trying to do a self-driving vehicle. And so the required level of confidence for the ROI could be different depending on the different scenario or the use case of the customer, but it is variable. There is a certain line on this confidence curve where it makes sense to deploy it based off of the use case and what the risk is and the ramifications if the confidence is wrong, right? And that's industry by industry and use case by use case. We see customers starting to come to grips that training data is an investment that they are making, and it's a continuous and ongoing cyclical investment. So they train, they improve their model, just like DevOps, just like any development cycle. You know, you improve, you measure, you test, right? And then you improve again, and you go through this cyclical cycle. So we're seeing companies now make these investments in training data. You know, going back years and years and weaponizing the data they have and going back and adding new dimensions and new metadata layers and labeling things that no one ever thought of 15 years ago when that data was first collected, right? And that's where we see the industry leaders. That's why you see Google navigation doing so well, just because they never ever stop improving the model. They have so much inbound data coming on. They're always identifying new edge cases and getting those edge cases mapped out into their model. So now we see this inverse curve here, which is the difference between the actual level of training required. Okay? And again, I'm talking largely supervisory training at this point. But we see this curve that says, okay, very early on, it didn't take much training to get pretty good high model confidence. But then as we drove up that confidence curve, it took more and more training inversely. And we see kind of 3 stages. And one of the big advantages that we have in my company is we see so many different projects from so many different types of companies. They're still all computer vision or NLP or entity relationship mapping or general labeling. But they're very diverse in what the outcome is that they're trying to achieve, right? But it's still, what do they need right off the bat? They need data, and they need data labeled. That's where they all start, right? So maybe right off the bat they were able to go find an open source, generally available data set, or they downloaded something from NIST, or they had 15 interns sit in there and go through the last 6 months of chat transcripts, and they were able to train their model very quickly to get to a point which was close to ROI. But then they get frustrated. They start to plateau in the value that they're getting from that because they run into the edge case block that we talked about. And that's when we start throwing humans at it. Okay? So we see this curve at this point where we have this requirement for human supervision. I don't know if you guys can read that there at the bottom, but where we have to do broad-scale human-supervised labeling or training data, right? And it has to be right. That's a big part of it. If you train with poor ground truth, if your ground truth isn't terra firma, then you are embedding problems in the future in your model because you're not giving it the foundation that it needs to be able to learn on going forward. So we see that usually ROI will occur in this phase 2 where we're dependent upon this high-scale human-supervised layer where companies can get it deployed, get their projects out there, get it deployed, start recognizing ROI on the project at that point. But what we see, and this is kind of where we get to the AI isn't for humans here, what we see is there's just a handful of instructions that these machine learning models will have going forward. And one of the simple instructions is going to be continuous improvement. Always look for deficiencies in the model, bring forward those deficiencies so that they can be stamped out, and continuously improve yourself. So these machine learning models over time will start having this insatiable drive for self-improvement, this mandate to continuously improve. So the chatbot got deployed. It got deployed at 82%. 18% of the people are frustrated and have poor customer experience. But that gets better and better the more the chatbot sees, the more the chatbot is able to suss out edge cases, the more the chatbot is able to get trained on those edge cases and see what the deficiency was, right? and experience gets better and experience gets better, that this insatiable drive for self-improvement is going to drive AI as close as possible to 100% confidence within their individual industries. And the people who are the highest to that confidence level are going to be, again, those differentiators within those specific industries. So AI and ML will have this inherent mandate for ongoing self-improvement, okay? And that's going to pull this, it's going to pull this requirement for improvement out of the data science teams and put it right in the technology itself, okay? Now we saw before that we had the, did I hit the wrong button there? I don't think I did. I imagine they'll get it back. You saw on the curve there that we had the human supervised on the bottom there. So now as we drive up even higher on this mandate for improvement and we're driving towards 100% confidence, the amount of training is just astronomical. It's just astronomical, the amount of training. Think how much training has gone into Alexa over the years. Think of how much training has gone into, you know, these fundamental, now second generation AIs that are out there that have the benefit of years of supervised training, right, that comes in. The models will seek self-improvement, and the data scientists won't have responsibility for that training anymore. It'll be self-recognition. The models themselves will be graded on how quickly they can self-improve. And this is kind of the cycle they'll take. First, the models will identify where their confidence gaps are, and I'll show you an example of this. But the models pretty quickly can identify, I have a gap in my understanding. One of our customers is a Fortune 100 insurance company. They take 10 photos of a car all the way around it to assess the level of damage on that car. They're trying to reduce the cost of insurance assessment and get a check out to the policyholder faster, but they need to be able to, within a high degree of accuracy, gauge the level of damage and gauge the cost of that damage relative to the make and model of that vehicle. So, you know, that creates that's a large amount of training when you start thinking about every make and model of every single vehicle. Well, new vehicles are coming out every day, right? So new vehicles are coming out, and suddenly the model will see a vehicle and be like, oh, I've never seen this vehicle before. My normally 94% confidence model is tracking at 78%. I'm not really sure what's going on here, but I'm going to collect enough representative data that I can send that out to a supervisory group, and I can fill in that deficiency in my model. And the machine learning model has to be able to do that on its own at some point. Right now, it's the data science teams oftentimes who identify those gaps in their model, reach out to us and say, hey, we've got 16 more use cases that we need to send you guys. Can you guys go construct those? This is, our most mature customers are doing this automatically right now, where they're just reaching out to us through an API directly from the AI model itself. When it identifies a deficiency, it collects a representative sample, and then it reaches out through an API to get supervisory data for that sample for ground truth. Now, what we're starting to see, and what probably many of you guys might be working on right now, is there's different options to collect that data. That training can come from different sources, right? And again, because of the inefficiency potentially in the amount of training needed to get higher up that curve, to hire humans to do that supervisory training on the way to 100% at some point will, fundamentally become inefficient. And so that's where we see a lot of people working really hard right now on self-training, right? On where we're not dependent upon supervisors, more unsupervised learning. Maybe we're looking at reinforcement learning if we have an indicator that we can compare against, some binary indicator that we can continuously compare against, or online learning. Online learning is probably even more common, or sometimes interactive learning, where we are in real time getting the blowback, the 18% that fell out of the confidence curve. And so that can be sent in real time to a human supervised group. That human supervised group can make a determination in the flow of the application, and it can start using that online data back within the flow. But the other thing is supervised data that's not coming from humans, but from very specific AI. And this is something that Alegion's working very hard on, where we have our own artificial intelligence that's able to make decisions for specific use cases, that are trained for specific use cases, where a human is not involved in the answer, where one AI says, I have a deficiency in my data here, reaches out to a second AI that is very specifically trained for identifying deficiencies in this area and is able to speak supervised data with a degree of confidence back to the first AI. I know it's kind of crazy to think about, but that's the preponderance of the training that's going to happen where it's AI to AI going forward. When I'm not going to be able to figure it out on my own, and when another AI is not going to be able to figure it out for me, I'm still going to be human dependent, okay, as this goes forward. If it's too gray of an area, if it's too much of an edge case, and I just require human input to get the confidence level of ground truth, then I still have this third route where I'm sending it to humans for domain-specific supervisory data. And then I can measure the outcomes. I can plug that in, say, okay, here was the representative sample. Here are all the Honda Civics, the 2020 Honda Civics I'd never seen before. Here's the data that came in. Did that improve my model for these Honda Civics going forward? And I can make the determination, do I need more representative sample to fill in the gap the rest of the way? So we're starting to see this quite a bit where the algorithms themselves are doing training. But as these algorithms interact with each other, as these models interact with each other, we're seeing the need for a new type of an API, a new type of an interface that may not be scripted like your traditional system-to-system API, right? It may not just be an XML handshake. It may not just be a JSON bridge that we can define, or a service bus that we can define the interaction. The interaction has to happen naturally like humans interact. And so when humans interact with each other, like many of you have done this morning as you guys are networking and meeting people you've never met, there's a number of things that you do innately. First of all, you try to identify, and we all have these little badges that we're wearing that give us at least some basic level of information about who you are, where you're from, what you do, what your level is, things like that. Basic identity. The first handful of questions we'll ask somebody is relative to their identity, because based off of that, we will innately assign some level of trust to that, okay? And that trust basically goes to, can I take your input, and where would I prioritize that input? As you're telling me, what it is that you do, how am I going to assign that in terms of trust from somebody else saying me that? We establish a level of trust when we talk with a person. Maybe we trust somebody more if they're from the same area of the country as we are, maybe not. And then finally, we assign a value to that. Okay, we assign a value, and that's that prioritization, right? So based off of who you are, and based off this gut feeling that I now have of how much do I trust you, or maybe it's referential trust where, hey, you've got to meet Ted. He's the smartest guy I've ever seen for computer vision. Go talk to him. Maybe that's referential trust, and so I'm assigning value through that through the reference. So we do a lot of that as humans innately. So why wouldn't we expect to see artificial intelligence take the same approach to it? So when artificial intelligence is interacting with another artificial intelligence, specifically around the use case of gathering supervised data like we're talking about here, it's still the same thing. It's still identity, trust, and value. So for identity, it's, who are you and what is your supervisory capacity, right? Why are you the person I should be asking to fill in the gap for this? Whether you're human or whether you're a machine, I want to know why you are the right person to be filling this gap for me. So first, it's identity. There has to be a mechanism for these systems to interact with each other and identify what they are and what their qualifications and skills are. Okay, so within our platform, we have thousands and thousands and thousands of workers all over the world who have specific skills and qualifications and capabilities, and those skills are put forward through an API where a artificial intelligence algorithm or a data science team can look through and select the groups of people that they want that meet their skill requirements. That's the same thing here, right? So from that identity, we can start putting together a trust matrix. And when you're an AI, that trust matrix has to be quantitative. As humans, we rely a lot on our gut, or we rely a lot on referential data. That's really tough for a machine. So a machine needs to see quantitative data. So how does trust inferred when we're talking about a machine? They want to see past performance. They want to see, like, eBay. What is your seller score? Show me all the totality of all the work you've done in this area and what your confidence has been. Have you been right or wrong in that? So how do we create and bubble up trust? And that's become a big issue of identifying and quantifying trust when a machine is talking to another machine. And finally, value. How does one machine assign a level of value to the input or data coming from another human or another machine? and it's economics. It's, number one, how scarce is this data? How hard is it to come by somebody who can speak this level of input into my application? Okay? Number two is how badly is it hurting me missing this data within my application? How badly is it hurting me not having a 2020 Honda Civic? Am I willing to take a lower quality person to fill in the gap partially, or am I willing to pay more because this person is very much in demand, or this algorithm is very much in demand? And that's the final point there, is what is the maximum input that I can get, the maximum value that I can get for this data given my budget? Because in this insatiable drive for improvement, these machines will use every dollar you have if you let them. So there's going to have to be governors. There's going to have to be budgets put on them and said, this is how much money you have to improve yourself, right? And this is all you can use. And so the machines are going to have to be able to do this computation of what's the max value given my available budget and the scarcities of these resources. So the way we approach it at Alegion is this exact same philosophical model. We have an identity matrix where we catalog the skills, the qualifications, and capabilities of human supervisors or machine supervisors, okay? And we present those qualifications and those identities through an API to the requesters. Then we have a trust engine. And this trust engine comes from scoring 100% of all of the tasks that go through the platform. We know exactly what the outcome of every single task from every single supervisor is, and we can demonstrate that to the inbounding request. So we can say this person is exactly 98.2% accurate when it comes to computer vision tagging for autonomous vehicles. Or this person is 67% accurate when it comes to sentiment analysis in Korean tweets. Probably not the person we want to grab within this model here. So we have a confidence engine that, along with the identity, allows us to drive to value, where we have a dynamic pricing matrix, where based off supply and demand, we can come up with a real-time price for how much is that resource worth, how many people want it at the same time, and what the value is that both to the worker providing the service or to the requester, the data science team, or the algorithm that requires that inbound data. And we send it out to human supervisors, right? We send it out to human supervisors here in the US, and about 50-50 here in the US and 50% offshore, depending on what the requirements of the customers. And we see that spread out a little bit. We see some customers say, hey, I just need the lowest cost possible. You know, just get it done. This isn't very sensitive. And then we have other customers say, this is immensely sensitive. We require these to be US people with passports on file. We need background checks. We need NDAs. We need them worked in locked facilities. So we call those private crowds, right? Where we need to sequester a group or have a group that has very specific certifications. I need PCI or HIPAA certificated workers for everything, right? So that's a privately curated crowd where they're working separate from what we call the general public crowd, like a Mechanical Turk or something like that. Or a compliant crowd, like we were just talking, if I just need HIPAA workers, for example, where I have HIPAA attestations and someone's signing a BAA on the file. Or maybe it's bring your own. Maybe I've got a contract with Unisys and I've got 15,000 people in Bangalore. I want to use them. I want to use their off time to do training data for our applications because we are already employing them. So we're pretty agnostic as to who the workers are. We're just the software in between that will give the end data to the customer. Now I got 1 minute left, so I just want to show you and kind of show you a basic walkthrough of that use case that I was telling you about. Again, the Fortune 500 insurer here, we get all of these vehicle images. We need to do about 25,000 vehicles for every type of vehicle or make, model, year of vehicle, because a 2016 Chevy Nova is different from a 2015. Do they still make Chevy Novas? Probably should know this. No, they don't. But it requires a huge amount of data. The complication of it is think of the facets of all of the edge cases around general damage. A car looks very different when a light pole fell on it as to when it ran into a light pole. Okay? So there's a high degree of diversity in the type of training required for this. And there's new data being generated all the time. So there's never 100% confidence. They're always driving to confidence. But the gap in confidence from 100% accuracy to wherever they are in their algorithm is very tangible, because it either means they're paying too much or they're not paying enough and getting a poor customer experience. So we came in there and put in a model that allowed them to very quickly have human supervisors and get to a point where they were above 80% in all of their training and be able to recommend, to augment their existing insurance adjusters where they had a recommendation engine, at least. It's not to the point where they can replace insurance adjusters, but at 80%, that gave them the ROI to augment, and then they had to basically defend themselves if they went against what the questions were, or what the recommendation of the engine was. Level 2 with them was, well, what if we start doing pre-labeling with our own application? What if they start using Alegion's pre-labeling, where we're using machines to do the labeling first, and then giving it to the humans to correct when the pre-labeling happens, which drives the cost of labeling down substantially when you're not paying a human for every judgment. When you take one human and make him worth 20 humans because of the machine learning within our application that's able to do the pre-labeling for the worker. And then finally, the customer understands the ongoing value in a continuing investment in training data, and they connect their algorithm directly with a platform that allows for continuous learning, continuous self-identification of deficits, and reaching out and finding responses to when those deficits occur. So that's about all the time I had today, but I just wanted to kind of give you a little bit of a view over the horizon of what we are seeing in the advantage point that we have, where we can see all of the different training tasks out there right now. And we can see, as a totality, the data science teams are trying to figure out how they can get the AI to be training itself, okay? Whether that's reinforcement learning, whether it's online or interactive learning, whether it's human-augmented machine learning. They're trying to figure this stuff out. So we got a big booth over there. Please stop by if you guys want to know specific information, or grab me as you see me walking around. But thank you very much, and have a great second day.